In this video, we will begin our methods on solving a differential equation. So like I said at the very beginning of the course, in this class, we will be solving a bunch of different types of differential equations, and what we're working on is really making it more intense as we go along. Just like in algebra, we started with a nice simple linear equation and worked our way up to crazy quadratics and cubics and logarithmic functions and stuff like that. So we are going to start with one of the simplest cases. You guys actually have done differential equations, hopefully, in your Calc 2 class. And nothing crazy, but just working on your integration, or maybe in your Calc 1 class, they would give you something along the lines. And let's start out real simple. I'm going to write a note here. If we just started out with like dy dx equals 3, right? You could tell me that, hey, my y, the function, is 3x plus some constant, right? Because you could just take the derivative of 3x and get 3, the constant would go away. But if I wanted to work on going from here to here, well, going this way was the derivative, so going backwards, we would integrate, right? So if I have a dy dx equals, like it's nice and pretty, I can just integrate going back. So like if I have anything that looks like this, and that's just the nth derivative equals some function, I can take integration back n times. So like for this equation here, since it's the second derivative, if I integrate once, I get the first derivative. If I integrate twice, I get the actual function, the solution. Remember, the solution to a differential equation is a function. We're trying to find what y can I use, take the derivative 2 times and get that. That's what it's saying. So we can use integration to work backwards if we know what the derivative is going to end up being. This only works when we have a single derivative, right? Or a single second derivative. It wouldn't work if I had a second derivative plus a first derivative. And we'll work on what do we do when that happens. So let's take an example of this. It just says solve the following differential equation. We'll go all the way through this. You should have seen this before. I am going to post on our Blackboard site some integration practice. This isn't homework, but if you feel that you need practice with integration, that would be a good thing to look at. We're going to use all techniques from Calc 2. The only thing we really won't get into, I think that usually won't come up, is we don't see a lot of trig sub. We do see a lot of integration by parts and tabular integration. So those will come up this week, so you'll have a chance to look at those. All right, let's solve this. So notice it says the second derivative is equal to that. We don't have multiple derivatives. We have one derivative equals something. So I can work backwards. If I wanted just the first derivative then, well, to get the first derivative, I take the integral of the second derivative with respect to x. Okay, so I'm going to do that. I'm just going to plug it in. So that's this whole function here, dx, and I just integrate. Okay, so I raise the power and I divide by my new one. This one's going to end up being a minus x cubed raised to 3 divided by 3. And then this last one is x squared divided by 2. And then don't forget the c1. And I'm going to do c subscript 1 because we're going to multiple c's. Right, that is what y prime is equal to. So now I'm here. How do I get from y prime to y? Well, if I want y, I take the integral of y prime. So that's the integral of what's there. All right, and the c counts as a number. It's just a constant there. So to get y here, I take my integral, okay, x to the 4th, go to the 5th, divide by the new one, and I just multiply what's at the bottom, so it's 20, minus x to the 4th over 4, minus I raise to 3, and then I divide by the new one, so I just multiply on the bottom. This is the tricky part where students mess up. That's a constant, so it gets an x, and then I got a c2. There is my solution. All you have to do is integrate. Something you already know how to do. Maybe it's been a little bit. This is your time to get it fresh on it. I would get fresh on your integration up front. Our methods are going to become more complicated very quickly. So get your integration down now. Refresh, go work the problems that I have up, or just go look at a few, look up maybe integration by parts or tabular integration, and just make sure that you can do some simpler problems. That way, when you face it in your homework, you're not totally thrown off.